Hi, everyone. Thanks for joining us, and welcome to OpenInfra Live, the Open Infrastructure Foundation's weekly hour-long interactive show where we share production case studies, open source demos, industry conversations, and the latest updates from the global open infrastructure community. We're live here every Thursday, 1400 UTC, streaming live to YouTube, LinkedIn, and Facebook. I'm Jimmy McArthur, and I'll be your host for the day to talk about all things green hardware. We're facing hard questions around climate change and a lack of global policy agreement that doesn't seem to rise to this urgent challenge. I'm excited to bring on our speakers today to discuss ways that their organizations are working to change all that. As I mentioned, we're streaming live and we'll be answering questions throughout the show. We'll try to save some time at the end of each episode for Q&A, so please feel free to drop questions in the comments section throughout the show, wherever you are watching, and we will answer as many as we can. Now, let's get going, and to kick things off, I'd like to go around and have everyone introduce themselves. Peter, why don't we start with you?
Hi, everybody. I'm Peter Pouliot, work with Ampere Computing in developer advocacy, and I've been a member of the Open Infrastructure / OpenStack Foundation since 2011.
Excellent. Laurent?
Hi, everybody. I'm Laurent Bernou-Mazars. I'm the CTO and co-founder of Exaion, which is a new EDF group subsidiary, big French utility company for those who knows. It's we're providing cloud services around blockchains, technology, and intensive workloads computing such as HPC and AI.
Excellent. Zac, go ahead.
Thanks, Jimmy. My name is Zac Smith. I work at Equinix. I run the Equinix Metal business unit, where we work to make it easier for our customers to deploy physical infrastructure across our 200 plus data centers in 64 markets around the world, and turn it off and on easier. Very interested in the sustainability conversations here today.
Excellent. And last but not least, John, why don't you go ahead?
Hey, hi everybody, John Miranda. I work at Intel Corporation. I work in Intel's Data Center and AI Strategy Office, where we track a number of topics. But sustainability has risen to the forefront as one of the topics we're also following, so I'm happy to be here.
Excellent. Well, thanks everybody. I'm happy to have you here today as well. John, we'll go ahead and start with you. Just kind of high level, talk to us about the green computing movement, and how open source initiatives like OCP and PCP are fitting into this.
Yeah, so on the movement part, I mean, we've been, in general, society's been talking about sustainability for decades. It's not particularly a new topic, but what we really noticed is a real sharp ascent into focus this topic is receiving, even in the last year or so. So if you look at, there's rising regulatory pressure in the industry. There's investor sentiment. Investor pressure is on a rise. So the expectations for the industry to do more are rising as well. So in terms of the green movement, we've seen CEOs of large corporations are all declaring goals such as carbon neutrality. But then the question arises, well, how do you go about doing that? And I think that's the phase we're entering, where people are starting to unpack, okay, the challenges are being issued, but in practice, then, it's a broad topic, and how do you start decomposing it? What actions do you take? And I think what many of us are realizing is no one company, we can all do our part, but no one company can turn this ecosystem in of its own. So, so when you start looking at movements like OCP, it allows us to come together as a community and drive more change. Speaking about OCP, so on November 9th and 10th is their global summit, and they're going to have a whole day dedicated to sustainability. So it includes, information sharing and kind of engaging the community to drive more action in that space.
Yeah, absolutely. And you mentioned how do we do it? we tried to get a wide variety of folks here today. We've got a couple of chip makers and Ampere and Intel. We've got Equinix on the data center side, and Exaion, who's got an interesting story around recycling HPC computers and giving them a second life. So talk to me, Peter, you're a member of both OCP and GCP, And Ampere is working to build dense data centers at the edge with more efficient chips. Like, what are the impacts that you're seeing in the work that you're doing, and is it making a difference?
Yeah, I would definitely say the stuff that Ampere is doing is making a difference, and I can talk about it from hands-on experience from what operators see in the data center once they start utilizing Ampere's chips in practice, in reality, right? So and to just give a little talk about that, I work directly with the Oregon State University Open Source Labs. The OpenStack project has a leg of the CI, for example, in there on our first generation processor. When I was working with the operator there, Lance, to stand up the infrastructure that we have there, when the power was first applied, and I have to preface this by saying, they also host infrastructure for the open power communities within open source, as well as other other infrastructure for builds and things like that. So he has a good perception of the power requirements down to the rack level for different platform architectures, right? And when he was there and lit up our racks, the rack of 12 of our first gen servers the first time, essentially they used less electricity than the top of rack switches, right? And because of that, he thought something was broken. And had to go get someone else to confirm because it's not, that's not typical. So from what it means in reality, right? Like as the infrastructure is changing, the demands are changing, they're requiring more power. As we move forward, the physical space that this equipment is going to consume isn't changing, right? Like the power going into that physical space isn't necessarily changing, especially when some of these data centers are on the edge for telco, right? Some of these buildings have been around for a long period of time. They have physical limitations in terms of what the available resources that can be pulled in. Efficiencies and maximizing that efficiency for the current model will help in both reducing not just the electrical consumption that we have today, but it essentially puts us on a path going forward to try to really optimize the data center stamp to take advantage of what's in there today and help us plan to go forward. So yeah, that's probably long-winded, but a little bit of everything.
Yeah, no, that's great. I mean, and speaking of size limitations, I think that Zac, this is something you're tackling head on with the Open 19 initiative. You mentioned to me it's more than just hardware. It's the rack size, it's the packaging, it's everything around the hardware too that's important for these green initiatives. So tell us how Equinix fits into all this and what you're doing at the Open 19 initiative.
Yeah, hey, thank you. I think the both Peter and John point on the complexity of this challenge, right? Which is that this is an ecosystem that frankly I think I want to pat ourselves on the back and say, from the incredible technology that companies like Ampere and Intel create, to how we get it into market, to how we enable it to be used by customers worldwide, we've made it pretty good, but it's actually an incredibly complex industry with lots of parts of the value chain that have to kind of evolve to help customers towards a more sustainable use of our capabilities and our technology in general. And one of the things which Equinix is the world's largest interconnected data center operator, we have a goal here at Equinix, a stated target of carbon neutral by 2030 using science targets. We're seeing our customers continue to ask us for more help. They're pushing it's no longer somewhere deep in the RFP that there should be some like ESG, side benefits or marketing. It's like number one on top, requests or demands from all of our Fortune 500 and Fortune 5000 customers saying, we need more help towards reducing our carbon impact, making our technology more sustainable, using it longer, all sorts of other things that come as part of that circular thing. And so what we're focused on at Equinix is, we see a lot of the technology land at Equinix. Unfortunately, we aren't in a hyperscale model where we can control what type of equipment our customers want to put in our data centers. And so we've sought out ways to work in open communities like Open19 as part of Linux Foundation, where we can help open standards around form factor, right? And so what we're thinking about here is primarily the advancements we need to make in conjunction with silicon and server manufacturers that also ripple into the broader retail data center. So think of things like more efficient use of power, like what Peter was speaking about. Chips are getting hotter. We're having to put more power in smaller footprints. How are we going to do that more efficiently? So having more efficient use of power supplies, conversion, different kinds of software-defined power that we can put the right type of power in the right place at the right time, and then cooling. And cooling is a huge portion of our world, the waste that we have or the impact that we have in use of water with evaporative cooling. We operate all around the world, some places that you can leverage outside air, some that you cannot at all. And we're getting into situations where we have a significant amount of heat that we have to remove from our data centers. So the question is now, how can we use that? So looking at a standardized liquid cooling coupler for plate cooling or single or two-phase cooling, how can we do that with facility scale, in the large-scale facility footprints we deploy that can work with a variety of server and silicon manufacturers so that we can adopt much more quickly an efficient way of using liquid cooling, not only to remove heat from the server, reduce things like fan waste, improve performance, on the silicon that is there, reduce evaporative cooling or evaporative water use, where we can actually have a closed loop system. And then, frankly, one of our goals is, well, I think it's not our goal, it's a requirement in order to hit our carbon neutral science targets, is we have to capture that heat. We have to use it to make new energy, sell it back to other places. It is currently a very, big waste that we do, mainly because we can't capture it. And so there's a lot of work that we have to do with our suppliers and a broad ecosystem. No one person can do it on their own. It's not possible, at least for the thousands of enterprises that work in, I'm going to call it the heterogeneity of multi-vendor, multi-location, footprints. So what we've done with Open19 is just work towards a standard on form factor within the rack, mainly thinking about how do we have a liquid cooling coupler that we can scale across our footprint that other OEM and server manufacturers can support, and how do we move towards more efficient use of power?
Yeah, I love that. I mean, as everything is moving to the cloud, everything is practically moved to the cloud already, and it's growing and growing. Having these efficiencies are going to be so important for every country in the world.
There's no other way. We got to make it better.
In France, they have where Exaion is located. Laurent was telling me that there's and forgive me for my French, but a raison d'etre, which is mandatory for every organization in France. So, Laurent, tell us about Exaion and your reason for existing.
This is the group, the EDF group, raison d'être. Is to build a net zero energy future with electricity and innovative solutions and services to help save the planet and drive well-being and economic development. This is a big challenge.
Yeah.
But we have to decline this in our domain. So for us, we use as many as possible low carbon electricity produced by our parent company. We also, as you say, give a second life to existing hardware because around 75% of carbon footprint of IT equipment is due to producing and to manage the end of life of equipment. And at EDF, we use big HPC systems, which was in top 500 classments. So thousands of x86 servers, high throughput and low latency networks, and multiple petabytes of storage array. So we decide to rebuild a solution with this 3 or 4 year old hardware. But we need to boost the performance, and for this we add chips and accelerators to existing hardware. We also work on technologies such as immersion cooling for to address the heat problem. We also work with the EDF Group subsidiaries, which is named Dalkia, around how to reuse the heat for to heat pools or farming usages or other kind of needs of thermical calories. We also provide for our services information around the CO2 impacts. So that's like a phone bill where you can have all the detail of I use this service and I have the carbon footprint impact to sensibilize the users around their own impact, because at every time there's not the same carbon footprint impact. There's moment where the electricity mix is made by carbon power plants.
Yeah.
And we can give this information to our clients to say, is it the right moment to launch a big HPC workload, or can you delay for 1, 2, 3, or 4 hours when the mix will be better?
Yes, no, I love this idea first of making your customers aware of what's going on and what their individual impact is, and also, you know, addressing things like time of day, time that you're using things. I can't remember who was talking about it, but someone was discussing the fact that ideally your refrigerator would only make ice first thing in the morning or overnight, right? And during the day it would turn off and you wouldn't make any other ice. And like these little types of tweaks can be done through technology.
Yeah.
And it's awesome to see this. You know, we talked also about the circular economy, and I think Exaion fits in that. Zac, what are your thoughts on you know, right to repair and the way I see it, EU kind of leading the way in legislation that, you know, that is helping climate change and helping address those things, as opposed to the US, where we're sort of lacking that.
Yeah, I think Laurent put on a few really interesting things, and I drew myself a little circle here because there's all these components, and the biggest one that you put focus on for me is like, how can we have less of a carbon footprint using technology? And the answer is not make the technology as often, use it longer, right? Use it for an extended lifetime. And I think there's two really interesting opportunities there. One, which is kind of in our control, I'm going to say easier, and that's to, at least like within an Equinix data center, for example, we're looking at ways at how we can take the rack level infrastructure of cabling and power and sheet metal and have it last much, much longer versus tearing it out every time we want to upgrade the computer. Right, and that's what we currently do today is with our kind of typical x86 pizza boxes. You tear out the power supplies and the rack level, networking and, cabling and related every time you want to upgrade the computer, which is on a very, very fast refresh cycle in many cases, while the physical infrastructure side is not on a fast refresh cycle. So having that extension of the physical rack level infrastructure is a big goal of what we can do. And then this other one is actually business model of silicon and OEMs, which currently right now is really incentivized towards helping you buy newer technology on a regular basis. And I think they're one of the big challenges we have as a community is move this what you were talking about, circular economy. It's going to be a requirement for people like John at Intel and Peter at Ampere to have business models, as well as our OEMs, which get paid, when the technology is used longer. And right now, that's not currently the economic incentive. And so I think moving that alignment is going to be a critical part to make sure that this technology has its full life cycle and that there is an incentive for it to come back in the right way, to be reused, recycled, put to another customer use case, et cetera, which today is not nearly as evident.
That's, yeah, excellent. And Peter and John, he called you out specifically. So, what are your thoughts on that as far as, moving some of these things to services and just generally adjusting the business models of silicon makers?
Yeah, I had a network hiccup, so I'm back in. Yeah, so we talked about efficiency, and I heard the tail end of circularity, but I think that's where the hockey puck is headed in terms of the conversation, moving from that linear model where we extract, we make something, we use it, and we discard it, to circular. And circular starts at design, and it's both hardware and software. So we need to think about the service life, the upgradability. When the software support stops, does the thing become a brick? Is it modular? Is it multi-generational upgradable? How long can that bomb go on? Can it be enabled into a secondary or tertiary life? So all these concepts begin at design. And so I think as an industry, we need to move towards that direction.
Peter, thoughts?
Yeah, and I guess to add to that, Ampere's been committed to disrupting our slice of the industry since our inception, right? The way we architect our chips, the way that we think about our platform lines and those sorts of things are all trying to remove the legacy kind of way of thinking about it and actually be disruptive in this space. So along the lines of some of the stuff that John just mentioned, like we ourselves have today an ARM SoC that is capable of having a socket, removing one chip from the socket and being upgraded to another, right? Which isn't typical for those types of things. So we are thinking about a lot of the points that John mentioned, as well as thinking about ways we can achieve efficiencies or disrupt the industry through some other mechanism that'll directly affect the performance of the system, the efficiency of the system, and the density of those cores in the rack themselves, right? To help carve a path for the future of this. But as it was mentioned by everybody here, it's there's a million levers to flip, right? Across lots of different things. And I can definitely say Ampere is committed to doing our part, and it's been a fundamental pillar of our existence from our inception. So yeah, I look forward to seeing and working with the rest of these guys.
How do you think? Oh, sorry. Go ahead, John.
Peter, you triggered a thought, that the million levers to pull. So I think one third angle that's really interesting that our industry can make some headway in is the idea that as we add renewable energy to the grid, it becomes harder and harder to absorb it because of its variable nature, when the sun shines or the wind blows. And yet the grid has to maintain stability between supply and demand all day long. So what role can technology play to behave as a virtual battery? So is there more work you can pre-do or work you can defer and align that workload intensity to when it's sunniest or windiest, and then relax that energy consumption at 5 p.m. when your energy profile is more fossil based. And that can extend to every device in our lives, from down to the refrigerator that can make extra ice cubes at 10 in the morning. And then the compressor works less at 5 p.m. And as far as the grid's concerned, your refrigerator is acting like a virtual battery. So as we think about, all the computation that's happening across all our devices, I think there's a transformation happening in energy as it's becoming more distributed. We harvest our energy, we store energy, we use our energy. So all these nanogrids, and what role can compute play to exploit and bring this energy more rapidly to the grid? Because if we're using solar energy, it's okay. What we're trying to do is avoid using fossil energy. So what role can we play to kind of accelerate that movement, I think is an interesting aspect to this whole challenge.
Yeah, absolutely. I love that concept, and especially as we're moving more towards IoT and edge, using every device as a battery is kind of an incredible concept.
Jimmy, maybe I can add a point there because Laurent touched on it about like exposing information, right? We don't do a great job in our industry about even having standardized ways or any kind of way in many cases to tell our end users who might be thinking of deploying the proverbial ice making job, e.g. running their, machine learning training job. We don't have a great way of telling them like now's not a great time, or now's a more carbon heavy time, or whatnot, or this region might have more capacity for you to do that in a better way. And so I think one of the areas of opportunities we have is really around figuring out standardized ways versus like, individual point solutions around exposing, the state of the energy and the carbon footprint of the resources you might be able to consume, and allowing you to do something about that. As people become more sophisticated with their workload management, with their software paradigms, orchestration, other things, how do we upstream, the developer experiences that are going to basically control this from this, pretty complex set of inputs behind the scenes.
Yeah.
Zach, my comment to that is welcome to the Matrix, right? So the reality of what you're talking about is kind of the direction that it's all going in, right? With the whole movement within IoT and sensor networks, right? Collecting the information we need to be able to compute on it, to make intelligent decisions that we then hit APIs that hit, trigger some level of automation to move the chess pieces around the board to achieve those goals, right? Like a lot of the fundamental Legos of each shade of color are being built, kind of as we speak, to start working towards that model, right? But as your point being, until we have the right technology in place to bring the information to the forefront, we're not even necessarily sure what we're dealing with. And although some of the other pieces in the background are there, we have to still do all the work to couple them together to get to a closed loop, right? To achieve the level of automation and visualization necessary to realize that dream, right? So yeah, I look at that as like when we're there, it's almost like it's well, we'll be in the Matrix, I assume, because it'll be managing itself.
So, Zac mentioned Laurent, and it raised the point to me that I mentioned earlier, EU legislation, in my opinion, is miles ahead of US legislation and regulation on climate change and climate policy. So I think it's fair to say the EU is leading the way. And as a result, at least with OpenStack, we've seen a huge explosion in public cloud growth because of data sovereignty and rules and regulations in that area. But Laurent, I'm curious, the carbon reporting you're doing, do you see something like that becoming a part of EU regulation moving forward?
Oh, this is a premise of the regulation. Today, that's not mandatory, but I think tomorrow it will be. I've heard that it will be next year, but I'm not sure that every provider could done it. But this is I think this is the future, and we need to do that because we don't have the choice. And also we need technology to do that. We talk about the idea of the matrix, but we need to have a machine to machine protocol and a full automized complex system. And for this, we believe that blockchain technology could be part of the solution to track and to automatize the contract between all the participants, and to incentive the end user or the company, or because this is we need to deal with the economical system we need to deal with. So we have to make an automatized system which could address that. Sorry, I've just changed the sense of the question, but I know that regulation is coming in Europe.
Yeah, and you know, for our U.S.-based companies, Ampere and Equinix and Intel, you're obviously global as well. You know, what do you think about the EU legislation? Is it something that, you know, you're working hard at your organizations to change at a manufacturing level and at a business level towards these green initiatives, but you know, should our businesses be driving legislation and lobbying Congress to make those changes in the U.S.?
As a global company, you know, the actions taken in the EU will affect large U.S. multinationals. And I think has been stated, you know, if you look at the energy footprint of compute and data centers, by the end of the decade, the estimates are very widely, but by some estimates, it could be 20% of total global energy will be consumed by the ICT sector. So it really behooves us on us to start bending that curve, so to speak, even as we're seeing nascent actions in the EU, but we're also seeing actions in the United States. Some states now, for some gaming rigs, when you go to order them from a major OEM, if you're in one of 10 states, you can't order it because it doesn't meet efficiency standards. So it's affecting the PC business already in the United States. So it's not just a EU thing. So I think that we're going to see more of this. So as an industry, it falls on us to take the lead versus being in a reactionary mode.
Yeah, I totally agree. And we're seeing it all across our footprint. We're also, you know, very, very global as an operator. And so, and we take it very seriously, hence why we signed ourselves up. We're the first major data center company to use renewable power, but exclusively throughout our portfolio, but it's still not enough. And so we set our science targets for 2030, knowing we wanted to help lead that, right? Versus just be in reaction to it. I think that's our responsibility to our world and our customers. I think one area I wanted to react on really quickly was, and maybe ponder a question for the group, which is, we have struggled sometimes, and we're seeing it right now, where kind of energy prices, you know, due to this transition to renewables in Europe, like, is very, very variable. And so we're, you know, kind of having these internal debates around what to do about that. Do we eat it on behalf of our customers? Are we just, you know, do we help expose it in ways and give options to react? You know, what do we do? And I think a question that we have is, you know, we see that potentially the kind of like sustainability and technology thing is moving past, like, you know, table stakes, right, to do business with us. Like, that's, we've always seen it as a branding kind of part of our brand, which is it's on brand for us to care about a sustainable world. And so we invest in that. But our customers often expect it for free. And what we're kind of getting into is that it's not going to be free. Like, as we move to net zero and to negative, it's not free. There's actually a premium for a lot of these changes. Have you seen any impact from customers? And how are you dealing with that? Do you think customers in the end are willing to pay for a more sustainable future, or do they just want it to happen with supply economics and, you know, everything else around?
That's a great question. You know, one area I was thinking about is, for some of our customers, they're also trying to meet their carbon neutrality goals. And one way they can do that is to buy offsets, and there's different qualities of offsets. So there's a cost to them to achieve their goal, and it's inclusive of their IT footprint. So if you offer them a more, and by the way, as more of us pursue these instruments, it strikes me that the demand is going to outstrip the supply. So the cost of buying these offsets is going to rise because there's more of us trying to buy the same thing. So they're going to incur a cost no matter what. So the question is there a role that, you know, the Equinixes and hyperscalers can play to hey, we can offer you a more attractive way to meet your carbon neutrality goals that may be more TCO friendly than you trying to solve your own problem yourself directly.
I would, and I think, you know, to comment on that, I think some of them are, right. You know, that's why, you know, I think Ampere has has a lot of opportunity, and you know, there's other factors at play too, right? Like the last 2 years definitely helped the rise of more, you know, consumption in the cloud is making them rethink literally how they build their data centers, because now everything has to be more efficient. You know, as the majority of us on this panel are in the US, like we're built on, you know, 100-plus-year-old infrastructure, right? There's tons of efficiency that could be done along every level of, you know, delivering power from the existing, you know, especially for our folks who may be in Texas, from the existing power infrastructure and grids into the data center, right? So if we look at, you know, all the technological enhancements that can be made to make, you know, the flow of power into the data center more efficient, the creation of that power more efficient, and you know, ultimately the computing using that power more efficient. I think you know, it's gonna force it's already partially forcing the issue both in regulation, in government, you know, through this, you know, current discussions that are being had, as well as you know, what's being teed up for the, you know, sort of the next wave. And it's all kind of, from my perspective, accumulating to a head, right? You couple this with, you know, the current security industry issues, and I think we are on the precipice of a wave of massive change in the data center that's being driven from, you know, those multiple points and coming to a convergence. Because much like, you know, securing things, you know, like you said, it's not cheap to make things efficient. It's not cheap to secure it either. So we're gonna get to a point where there'll be a penalty, I believe, if you're not going to do that stuff, because there's an inherent risk to the cloud operators or service providers from their customers who aren't taking a proactive approach, right? And that increases the liability. So from my perspective, you know, standardization is key. Regulation is going to come out of, either is going to help drive the standardization, or in some cases we're seeing, you know, the industry driving its own standardization because, you know, or the customers driving their own standardization, like in the case of OCP, to force the industry to make change, right? And you know, think about it, OCP has been around for quite some time now, and only in the last few years are we seeing the effects trickle into consumer level devices where you can get, you know, OCP compliant hardware that is off the shelf, right? So, you know, it obviously is going to take a lot.
I mean, I have a comment on that, which is I think that, like, especially for the broader enterprises versus the pure digital service providers, like, we have to figure out how to involve OEMs. And
absolutely.
That's where the OEM, the OCP construct is really going to be difficult to bring OEMs along, right? ODMs, yes, but OEMs, it's really hard because it's, you know, the IP ownership structure really is, you know, meant to remove a lot of their value chain. And so I think, like, just given how we see technology reach enterprises, we need to figure out how to bring OEMs and other kind of what I'm going to call proprietary technology companies who monetize their technology in that way along for the ride.
Welcome to disruption, right? That's why we're all, you know, working in open source, because we've all agreed to standardize on some level of technology and move ahead on where we can compete, right? So it's going to happen, and I think in the rest, you know, that's going to happen in other parts of the industry as well. There's going to have to be a standardization revolution to occur, right? And we're all going to have to give something up to get to that. So, and we all agree here that it's, at some level it's necessary, and it's going to be, and at others it's going to be mandatory. So,
it was touched on earlier on standardization. Maybe one area that we can all agree on is the importance of measurement, because if you can't measure it, you really can't manage it. And if like, let's say I'm a medium-sized business and I run payroll for 1,000 employees. How much energy, what was my carbon footprint? Like, and would it have mattered if I run it Tuesday at 7 a.m. or Tuesday at 4 p.m.? Or would it have mattered if I ran it in a data center in Atlanta versus a data center in another part of the country? So how do we get to a point where we can expose to those end compute users the carbon footprint and motivate them? Maybe it's a form of congestion pricing, if you will. Motivate them to make the right decisions. They may want to make the right decisions, but without the measurement and the data, they're in the dark. And so I think that's
I totally agree,
issue.
John. And I've been inspired by like what Stripe's done with their climate project, where they have made it so consumer simple for businesses to turn on 1% of their transactions to go toward climate, carbon capture, which is, not a very at scale market, but they've made it so productized. And that's something where I think we have a lot of work to do, is taking that information and productizing it as part of what we do and saying, here's how you can use it, right, in a more repeatable manner, versus maybe some of us who are highly passionate and involved in doing this as our job, right? There's a lot of end enterprises like the payroll, running of the payroll software, which they just need it productized so that they can use it, that information.
So this is awesome, but we've got a quick question coming in from the audience. Thomas Goy asks, at Raid Boxes, we aim to be CO2 neutral, but the idea of processing data where the footprint is better sounds interesting, but it's a very complex gap to solve in a hosting setup. Anybody want to take that one? Peter, Zach?
Well, I'll comment. That's part of the opportunity for, companies out there, right? Is solving those types of problems. Yes, if we want to be able to, move compute workload at ease, dynamically on demand, we not only need the data, but we need the technology to support it, right? We've talked about things like cloud bursting for like 10 years yet, but still the seamlessness and what that really means isn't fully realized yet, right? So from a mechanism perspective, in order to enable, those things, the technology has to evolve and it has to present itself, and there has to be, big companies and providers working together to ensure that the doors and are open and capable of handling those types of activities, right? So there's a big technological aspect that has to be enabled to get to the point where you can shift and dynamically move workloads globally as to meet your pricing. And that's where the opportunity is to me lies for the industry to capitalize on.
Laurent, any thoughts on that?
Oh yes, I think it could be maybe done by decentralizing the IT system. We can do this. I know that we can do this now with the big cloud providers services, and we need to be deployed on different sites and different maybe countries and different grids, electrical grids to do this. Technically, I think it should it necessarily should be done on an open system because we need to interpret, to have the data to interpret, and to be ready to start. I don't think that the workload should just move, but it could be built and launched on the in the good place.
Yeah, I have a
So,
piece of feedback on that, which is that we use a term internally at Equinix called how to move physical infrastructure at software speed. When in reality, these are very, very physical components, right? Building data centers takes time. Ordering computers is a long lead time item. Installing them is very complicated. And what we do right now as an industry is we really work around a kind of like, how do we get things into the data center? And a lot of the innovation has been done in hyperscale, which is how do you get a lot of the same thing into a few data centers? And we have this other problem, which is how do we get a few things into many places? Or how do we move them more efficiently and cheaply from one physical location to another? Like the whole concept of rack and roll, or taking your entire pre-built rack and putting it in, only works for a very small subset of the world. And then the efficiencies, we see it in Equinix because we charge people hundreds of dollars an hour to kind of move a cable, right? Or to put a server into a rack. It's extremely expensive. And it's not standardized at all. There's no standardized cabling understanding or power. And as we get more complex with the power and the cooling and the related, we have an even harder problem. I look at it as the difference between, making completely craft coffee versus an espresso capsule, right? We don't have any sort of Nespresso capsule for data centers because everything is bespoke once it gets into a 19-inch rack. And so I think there's some big opportunity to address Thomas's challenge of, right now, once you put equipment into one place, it is almost impossible or not at all worth it to move it to another place. And we have a lot of work to do where we can make that technology infinitely more reusable. Oh, we don't need it as much there. Let's move it someplace else. Oh, this customer doesn't need it anymore. Let's reuse it in another place. Or, hey, we put it in and it's time to refurbish it and add something to it. Let's make that more circular. Right now, so much of the friction is actually in the installation because we've never thought about how we get it out and reuse it in a kind of reasonable manner.
I'm having pets versus cattle flashback right now because that's essentially what we're talking about, right? Disaggregating the everything from the hardware itself, right, to provide a layer of flexibility and movement. Yeah, that's
Yeah, I think there's a technology approach to it, which is I believe you and Intel and related are working on awesome ways to re-envision our architecture to be more fungible, right, throughout things. And then we also have a physical thing, right, which is just how do we make form factor and physical aspects more portable and less friction free. And this can get itself down to, in our industry, like a standardized reusable packaging model, which we don't have right now. We have a lot of cardboard that goes into our data centers, which we then throw immediately out. It is impossible to repackage those computers and put them anywhere else. It's very, very expensive. And so even just getting into like working on standardized packaging could remove a lot of this friction that currently doesn't allow us to reuse components.
Yeah, and I'd say from the software side, this is where OpenStack comes in. Is we're trying to solve this through interoperability and being able to, lift and shift your entire workload over to another set of VMs, another set of servers, ideally. Where I think where we struggle is still at the public cloud level. Not being able to move from one public cloud to another because of federation issues and metering and monitoring issues that I think still need to be solved. But it in an ideal world, everyone's running OpenStack, and we can just run anybody's workload on any public cloud or private cloud that happens to also be running OpenStack, and then we kind of solve some of that hardware problem as well.
So I want to make a comment to one of Zac's points earlier. You mentioned about like adoption of a lot of the kind of advancements that were made from the hyperscalers that's driving some of the technology. Along those lines, I think one of the things we need to do, much like OpenStack, when it came about, address the idea of scale. This is also just another scale problem, right? Like these advancements are being made by hyperscalers. We need to scale them down, right, to be applicable to enterprises, edge, other use cases, right? Like I guess cherry pick the things that work best and figure out, ways to apply them to the, to the smaller stamps that are out there. And I think once, that's gonna, as things typically happen, that
Yeah.
will eventually happen, but it always takes time, in cycles. So
It's a great point. I mean, this is the, solar cells reach point where now it can be widely addressable by my neighbor to put on their roof, right? This has to happen at some point in these larger, kind of more complex systems as well for technology. Yeah.
Yeah, I know. And
Yeah.
Oh, go ahead.
Yeah, I was going to say the interoperability is going to be really important. We talk always about the public cloud, but the reality is the end result for enterprises is going to be hybrid. There are some things that will not go in a public cloud. You got major manufacturing sites, the data is there. You need to maintain that kind of isolation of keeping the compute localized to where the manufacturing process is happening. You're not going to put that in a public cloud. So we got to think in terms of a hybrid end state, which is inclusive of multi-cloud. And I think interoperability is going to play an important role there. And that can also be connected back to sustainability.
We've got, I think, probably time for one last question here. John from Texas is coming on with how do the opposing forces of standardized hardware and rack configurations versus increased demand for specialized hardware, GPUs, CPUs, et cetera, play into that push for portability?
I would love to take that one for 30 seconds. I personally believe we're in a more, although it would be convenient for us to say that we're going to have a homogeneous infrastructure, substrate that we could really build this scale around and whatnot, that we're actually going to have a very heterogeneous infrastructure world. That part of our job here is, like, as workload becomes more important, we're going to, Intel and Ampere are going to make specific chips that do one thing really well or do one thing best, right? Like, we're going to have accelerators and unique workload that happens much more, I'm going to call it not bell curve like, right? There's going to be the anti part of the bell curve. And I think that that's a huge opportunity. We have to recognize it versus push against it. Because right now in compute, we have this kind of commoditized 80% should run on all the same stuff thing. And it actually might flip, where more stuff, Laurent, is looking like HPC and less of it is looking generic. And so I believe that we have to work that into our standardization, not in terms of all computers look like this or all computer racks look like this or whatnot. And hence why I'm very focused on form factor. And I take inspiration from the PC world of ATX cases. You could put almost anything in an ATX form factor, and everybody knew how to build an ecosystem around that. If we could build an ATX case for, the mechanical sides of racks and whatnot, then we wouldn't be flipping and moving our power supplies from left to right and flipping and moving our, cables on our NIC from here to there, which creates massive complexity in the in-rack data center side. So maybe it's more, think about the area that we standardize in. Is it in the ATX case of the rack or wherever? And then allow lots of diversity within that. I think probably Ampere and Intel can speak more to being able to more fungibly use disaggregated components across the network or whatnot. That would probably make this a lot easier.
Yeah, I think.
Sorry. I was going to say, having done a lot of automation, the things like how easy it is to plug in a cable, when you're automating entire data centers, that increases your failure rate of like precision, right? Like your chances of screwing up, pulling the MAC address off that, like all those things increase. So consistency and precision around those things in the data center definitely affect your ability to operate it at a high level, and will affect the cost of that through the suck of time and effort, right? To go and troubleshoot and find those issues because of the lack of standardization, right? So I digress. Sorry,
John.
Yeah, and I wanted to add to Zac's point, on the case, thinking about modular designs, which are more, kind of, you can upgrade a piece, but leave the rest of it alone, because there's a carbon footprint on the fan subassembly, the power delivery, all the metal, all the stuff that goes around the actual FPGA, GPU, CPU. So can you preserve all that even as you upgrade or modify one of those components? So I think thinking about kind of more modular designs is an important aspect here.
Well, this has been an amazing discussion. I think we're about out of time, but I want to thank you all for coming on. It's been a really interesting and super thoughtful discussion. So with that, we have another great episode coming up next Thursday, focused on hybrid cloud, kicking off a series of episodes to talk about organizations deploying hybrid cloud environments and the technologies they're working with, and the vendors who are supporting the production use cases. And we've also got a very special 2-day episode coming up in November, and we hope you can join us for OpenInfra Live keynotes on November 17th and November 18th, our biggest event of the year. So register now at openinfra.dev/live/keynotes. And I want to say again, thanks to our guests. I appreciate Zac, John, Laurent, and Peter for coming on, and it's been a real pleasure.
Thank you.
Thanks for having me.
Bye.
And remember, if you have an idea for a future episode, we want to hear from you. Submit your suggestions to ideas.openinfra.live, and maybe we'll see you on a future show. Mark your calendars, and I hope you're able to join us next Thursday at 1400 UTC. Thanks again, and have a great afternoon.